Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we're going to be going over section 4.2, Relations and Functions. With mathematics, you have to know what you're talking about before you can really get anything done. So the first thing we're going to start out with is a couple of definitions. The first definition is a relation. A relation is a pairing of a set of inputs to a set of outputs. A relation is a pairing of a set of inputs to a set of outputs. For an example, let's say that we have a set of superheroes, and those will be our inputs. So we have input over here, and then we have our superheroes and their names. We'll have, let's see, what are some good superheroes? Let's see, Spider-Man is pretty cool. So we got Spider-Man, Batman's pretty awesome. Some other really awesome superheroes. Let's go with Green Lantern. And Professor X. And on the outside, we're going, and what list wouldn't be complete without Superman, of course. And then for the outputs, we'll have villains. People like Bane or Magneto or maybe Dr. Octopus or Doc Oct. Who are some other big bad guys out there? Darkseid. And Doomsday, and I think that'll be it. Okay. Oh yeah, Venom. Can't forget that guy. So what we're going to do is we're going to pair our heroes with one of their main villains. So for an example, we have Spider-Man. Spider-Man has two villains on this list. The first one that he faces a lot is Dr. Octavius. And the second one that he faces a lot is his counterpart, Venom. And then Batman, of course, he has a villain on this list in the name of Bane, because in the comics, Bane broke Batman's back for a little while. Green Lantern is part of the Justice League, and he's had to face several of these guys, including Darkseid and Doomsday. Professor Xavier is, of course, part of the X-Men, and the X-Men's arch nemesis is, of course, Magneto. And then Superman, well, we'll go with a manly color for Superman, mainly pink. And he's had to face Darkseid several times, and he's had to face Doomsday. So this is a relation because we have a set of inputs. Our inputs are, of course, superheroes. And our outputs are, of course, their villains. The people that they go up against all the time. So a relation basically pairs some group of things to another group of things. Now, next on our list is another definition, and this definition is called a function. And remember, you can't have a function without fun. A function is a relation where every input has exactly one output. So obviously this is a little bit different than just a normal relation. A function is a special type of relation. It's a relation where every input has exactly one output. So let's look at the example that we have already. We have the Spider-Man, Batman, Green Lantern, Professor X, and Superman, and then we have Bane, Magneto, Darkseid, Doomsday, and Venom. In this one, you'll note that not every input has exactly one output. For an example, Spider-Man here has two outputs. He has Doc Ock and Venom. And Green Lantern has two outputs. He has Darkseid and Doomsday. And then Superman has two, Darkseid and Doomsday. But Batman and Professor Xavier in this particular case, and I don't know why I did that, but Batman and Professor Xavier both have only one villain, so they only have one output. So this is not a function. This is not a function because we have at least one input that has more than one output. Now let's look at some alternatives. Let's say that we have our input is the following: the Atlanta Braves, the Seattle Mariners, the Prospect Cougars, let's see, what other teams are there? Oh yeah, the Boston Red Sox, and the Tokyo Dragons. And then we're going to have some outputs. And the outputs are going to be American League, National League, and the Japanese League. I'm going to call it the JL, which is kind of like Justice League, but not quite. Probably way better because, you know, baseball's better than comic books any day of the week, in my opinion. All right, so if we're looking at this, we have the Atlanta Braves are an American League team. Sorry, a National League team. Oops, wrong way. And then we have the Mariners. The Mariners are an American League team. The Cougars are in neither the American, the National, nor the Japanese League, so they don't go anywhere. The Red Sox are an American League team, and the Tokyo Dragons are a Japanese League team. Now, is this one a function? Well, the answer to that is no, mainly because of the Prospect Cougars. These guys have no output. So if you remember, our definition says a relation where every input has exactly one output. Well, here's an input that has 0 outputs. So no, that's not a function. Now, let's replace the Cougars with the Houston Astros. Now, up until recently, the Astros were part of the National League. However, about 2 or 3 seasons ago, they were transferred over to the American League. Now, is this a function? Again, no, because the Braves, the Astros have 2 outputs for 1 input. So that doesn't quite work out. Now, let's say that we just remove the Astros entirely and remove the Tokyo Dragons. Now, is it a function? Well, looking at it, every input has exactly 1 output. Yes, the American League is picked twice by the Red Sox and the Mariners, but that really doesn't matter. What matters is that every input has exactly 1 output. The Braves has 1 output. The Mariners have 1 output. The Red Sox have 1 output. It also doesn't matter that we're not using the Japanese League at all, because every input has exactly 1 output. So this one is a function. So I'm going to write that over here. This is a function. A function is a relation where every input has exactly one output. Now we're going to move on to how we show this mathematically. Mathematically, we have our function, which has our inputs. Now our inputs, which we call the domain, are usually our x values. These are x values, which means that they are the independent variable. Remember, the independent variable is on the horizontal axis, the x-axis. And why is the x-axis horizontal? Well, because we usually prefer our x's to be horizontal with 6 feet of dirt on top of them. The inputs are also our domain. You go into someone's domain. For an example, if you're going to be Lex Luthor and you're going to visit Batman, then you are going to go into Superman's Fortress of Solitude, into his domain. And then we have the outputs. And the outputs are the range. Remember, you go out to the range. You don't normally go into the range, because if you go into the range while people are doing target practice, you're probably going to get shot by accident, and that would make everybody very, very sad. So don't go into the range, go out to the range. And because there are outputs, this will of course represent our y values, or our dependent variables. And if you remember, the dependent variable is the y-axis, which goes up and down. And remember that the y-axis goes up and down because if you know y, then you can ascend. So our inputs are our domain, our x values. Our outputs are our range, our y values. We have the independent variable, the dependent variable, and then we have something called ordered pairs. Now, ordered pairs are a set of things that are paired together. You know how earlier we were pairing something like the Braves with the National League, or Superman with Doomsday and Darkseid. Well, the same thing is going on with the ordered pairs, except instead of using things that are characters or organizations, we use numbers. And this is so that we can better see the mathematics, the arithmetic behind things, with a visual representation. So our ordered pairs always come in the format of x, y. X is our independent variable, it is our input, and y is our dependent variable, it is our output. And then we can put them on our axes by looking at different types of pairs. For an example, if I have the pair 2, 4. Because it's an ordered pair, I know my 2 is my input, and then my 4 is my output. That means that the 2 goes on the x-axis and the 4 goes on the y-axis. And why my computer keeps doing that, I don't know. So what I would do is I would go to 2 on the x-axis. So that's 1, 2. Note how when we go to the right, we're positive. When we go to the left, we're negative. When we go up, we're positive. When we go down, we're negative. So I would go 2 to the right. And then 4 being positive means I would go up 4. So we're looking at 1, 2, 3, 4 going up. And there would be my point at 2, 4. Now please remember, order does matter. So what would happen if I had the ordered pair 4, 2? Well, then I have 4 on my x-axis, so I go to the 4th place on my x-axis. And then I have 2 on my y-axis, so I go up 2 spaces, and I have the point 4, 2. Note that these 2 points are not the same location. They're different points. They're different locations. So when it comes to ordered pairs, kids, order matters. Order most definitely matters. Oh, that was supposed to be there. All right, so let's go ahead and move on to our next piece, which is dealing with some different types of ordered pairs, like with negatives. For an example, what if I have the point -2, 4? Well, the -2 is on the x-axis, so we're going to be going 2 in the negative direction. The 4 is the y-axis, so I go up 2, 4, and I have my new point at -2, 4. And what about the very manly point, -4, -2? Well, then I go to the left 4 spaces, and then I go down 2 spaces, so that I'm now at the point -4, 2. And the last one, let's go with blue. Let's say for a moment we have a point at 4, -2. Where would that be located? Well, for that one, we go to the right 4 spaces, and then we go down 2 and make a dot. That would be the point 4, -2. Oh, I forgot to put the negative over here. So each quadrant has a different style of numbers. This first quadrant, which we're going to call the top right-hand quadrant, is quadrant 1. And its numbers appear as a positive x value and a positive y value. Then the second quadrant, which would be to the left in a counterclockwise fashion, has points in the form of a negative value and then a positive value. The bottom quadrant, or quadrant 3, which is below quadrant 2, also has a pairing where it has a negative x value and a negative y value. And the final quadrant, which we will call quadrant 4, has a positive x value but a negative y. And that's it for this section. We have 4 quadrants, we have 4 different pairs, we have an input, we have an output, we have a domain, we have a range, and that is that. So let's go ahead and go to your favorite part of the lesson, homework. And for this particular lesson, you will be doing the following problems. There we go. Oops, wrong button. Oh no. Oh well. So on homework, we will be doing section 4.2. Which is on page 243. And we're going to be looking at numbers 1 through 27 odd. All right. Good luck and have fun.